All right. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. We are going to pick up where we left off, almost exactly where we left off last night, in our implementation of our avatar system / player state machine, all that goodness. So that is what is on the roster tonight, and I've got a little bit of a list up here of things I'm hoping to accomplish tonight, so we'll go through that in just a second. But before I do want to just take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Alazaran, followed by our partners, Gerbolis Inc. and Matt Oscard. These are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here. Scrolling by the screen, those are the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for that support. It is greatly appreciated and helps me cover the cost of running this project and channel, things like software licenses, hosting fees, and eventually assets, things of that nature. So just a big shout out to you guys. Thank you very much for that support. I greatly appreciate it. And of course, I would be in error if I didn't give a big thank you to all of you, the viewers, whether you're joining us live here on the YouTube side or the Twitch side, or if you're just catching the VOD after the fact. Without you guys, this project would not be. And so thank you guys very much for being here. I appreciate each and every one of you guys. All right. So tonight, or I should say, I guess we could do a quick recap of what we did last night. I did one or two things off camera, but they're very, very minor. So we kind of decided what we were going to call these various things that are going to exist in the world. And we're going to call them avatars, right? And that's going to ultimately be what we base our player off of, at least the physical representation in the world. Our monsters, NPCs, things like that. They're all going to be avatars, right? And then from there, obviously, we can extend those. And so we started putting together an avatar system last night, and we got probably about 90% of it scaffolded. All the way up to our full final design of loading in configuration, right? So there was a let's see. This is what the player avatar configuration will look like. So there's a name, there's a model always associated with it. So that's the asset name and the package name associated with that. There's sort of a default transform that we use with that. And then there is in fact, actually, I should probably, let me see. Maybe I should reset this to just be standard rotation, right? Because we probably don't want, the only thing we really care about in this is actually position. So while we're doing that, let me go ahead and just simplify this a little bit. So we have triple zeros on XYZ, then 1, 2, 3 zeros, and then 1 for our quaternion, which is going to be our identity quaternion, right? And in this case, the model is kind of huge, the test model that we're using, so we've scaled that back quite a bit. So this is the default transform that we're going to use for this particular avatar. We also have a hit shape in here that has a sphere and a radius, sphere type rather, and a radius of 1.0, and that is going to be used for the interaction of a bunch of different things right now, mostly for interacting with the zone change. So if I run the application really quickly, what that's going to represent, which is currently hard-coded into the scene right now, is if I walk the character over here to this yellow orb, which is a trigger, we can see here that we now have the ability to travel to another zone, right? And I don't have that zone set up, that's fine. But if I were to hit F, it would try to load level and, ultimately fail. So we can set that up at a later time. The important part is all those pieces are hooked up and working. So the next bit is that these avatars have states, and this is kind of where the state machine aspect of it came into play. And so we kind of set this up just as a reminder of how this is going to work. We have all these individual states, most of which are associated with an animation. And then we have a list of from, which basically says we can transition to this idle state from any one of these other states, right? So we've got an idle state, we've got a walk state, which can only be transitioned to from idle or run. We have a run state, which can only be transitioned to from idle or walk. Jump could be done from idle, walk, or run, etc., right? Attacking can only happen from the idle state, right? So we've got all that. And the other thing that isn't here, but is another important piece that we stood up last night, is we essentially have the ability to load function pointers for functions if they happen to exist in code. And that allows us to actually handle logic for when we're entering a state, when we're leaving a state, or when we are updating within a state. And so if those function pointers exist, then it goes ahead and uses those. So the way that those are named is evident here. So it'll be avatar underscore, and then it'll be the avatar name. So in this case, it'd be player, and then another underscore, and then it would be the name of the state, which would be idle in this case. And then, on enter, on leave, or on tick. And so what this logic does is it basically goes through and says, do we have a function by this name? If we do, let's go ahead and assign it. If we don't worry about it. And so those are automatically essentially called by convention. And then if we come down here to our, where is it? Our update loop, actually, I think that's further up. We can see an example here of when we go through to update the system, all of our avatars are looped through, and any active avatars, if they have an onTick is called. And then we have a transition state, which might actually be towards the bottom. Yeah, state transition, rather. And so this says, basically, this avatar, we want this avatar to transition to this state. And so we basically assert that that's going to be a legal transition. And then from there, we say, hey, if we have an on leave for the current state, let's go ahead and invoke that. And then we'll go ahead and get the new state, set those things, and then call the on enter for the new state. And that is basically the way that works, right? It's pretty lightweight. It's pretty straightforward, I think. And so we've scaffolded all of that last night, and we are going to extend that tonight and integrate it into our game code. All right. So where we left off was I kind of typed up this list offline. And actually this game lib hot reload all PFNs for every avatar state. We actually have... That is something we need to do. So one thing is whenever we reload or we do a hot reload on the game library, one thing that we lose every time we do that is the address of all function pointers, right? And so this system needs to be able to handle that. We've got a few dozen other places that we haven't handled that in a while. And so hot reloading of that is broken right now, but we do eventually need to fix that. And so I'm designing this with that in mind. And so that's one of the quick and kind of easy things that we can go ahead and knock out. So with that, I think what I might do is, since we come through here and we actually do a on enter, right, for the states, if we take a look at the structure for that, since we go ahead and set up the function pointer here, let's go ahead and also do, let's see. I guess we can go ahead and do, should I store the string? No, I think I'm going to store a kname. Let's go ahead and do a kname. And we're going to call this on enter function name or just name? I guess just name, right? And then we'll do, let's actually move this down here. And then we'll do kname on leave name. and then we'll do one more kname on tick name, right? And the advantage to storing those is we could basically say at this point, so if, let's see, I suppose what we could do, let me think about this for a second. I guess we could always just save it, whether or not it's actually found. I think that's fine. If we need to fine tune it later, we can always do that. So we can do a states sub I on enter name equals kname creates. Whoops. Kname create. And then we'll just do on enter name there. And so we'll just need to do this 2 more places. So we'll do on leave name, and then we'll do on tick name there, right? So we'll store that. That way we can very quickly and easily look that up later. And what this will allow is, the reason I'm not hinging this on whether or not this exists is because we could actually create this function in our game code where it didn't exist before and hot reload and have that new functionality if we wanted it, right? So it just kind of makes that whole thing a little bit more flexible by doing it this way. So we have that. So I think the next thing I'm going to do is I'm going to keep this loop here. I'm actually going to take all of this, and we are going to put in one more thing. And I don't 100% know what the function signature is going to look like for this, but let's actually go ahead and put it down here at the bottom. Let's see. Let's actually put it all the way at the bottom. So we're going to say void avatar system on lib hot reloaded. And I don't know what arguments that's going to take yet. That's fine. So what we need here is we are actually going to need the state, which, how are we going to get that? We need to take that as an argument. So we're going to need the struct, or I guess we could just say avatar state. State. So we need that. And then throughout our avatars, right, we have the avatars here. We actually need an avatar count. So we need a U32 count equals states avatars. Wait, states. No, not avatar state. We want avatar system state. There we go. We want states avatars, and that is a D array. So we're going to need a D array length of that. Oops. Right, and then we'll do a for U32. And I guess we'll just call this one J, right, since we already have an I. J is less than count plus J. And then what we'll do is here, we'll go ahead and get the avatar. So we'll say avatar state. Was it avatar state or just avatar? Just avatar, I think. Yeah. We're going to do A equals the address of state avatars sub J. Right. And so what that's going to do is anytime this is called, the avatar system is going to hot reload or reload all the function pointers for all of the states in all of the avatars. So that's an important piece of the puzzle that we were missing. So I'm going to go here and put this just in the header file. And we'll go ahead and get that included into the engine as well. Apotham, good to see you. How's it going? OmniStack, good to see you. Have to say your NVIM setup and background is beautiful. Just started your Kohi series. Awesome stuff. I appreciate that and welcome. I hope you find it useful. Syed over on the YouTube side. Hello, how are you doing over there? I appreciate the kind words as well. Welcome. Okay, so there are a couple pieces that we need to fit in to get this to actually be hooked up to our game code, right? So I'm here in Illumina main over here on the right. And this is in the application initialize, right? This is where we actually stand up some of our other systems. So we've got our zone system here. We've got our context sensitivity system. I think it's safe that we can go ahead and just put this right at the end of that. So I'm going to say avatar system. All right. And what we're going to do is, let's see, I think I'm actually just going to, instead of doing this whole pattern like I've done elsewhere, I think I'm just going to assert this. And so what we're going to say is we want avatar system initialize. And I forgot that we don't actually have to do this pattern because we didn't do that for our game systems. So all we really have to do then, let me edit this real quick. We don't need this. We don't need the memory requirements. Oops. We just need the state and the app. So here, we don't need this. Just need the state and the app. Okay. Okay, so we need the state, right? Which we don't actually have. So let's see, do we have to, I don't think we need to, I don't think we need to dynamically allocate that. I think we can probably just go ahead and put that here. So we can do the avatar system states. And we'll do avatar state, right? And so here we can just pass the address of avatar state. Or whoops, what was it? App state, avatar state. That's what I wanted. And then we also want to just pass app along with that, right? So we want to make sure that that stands up correctly. And that's all we actually have to do to stand that up. Let's see. So the other half is going to be in the shutdown. Well, there's a couple pieces, actually. We have the update piece. Since we're in this loop, we might as well go ahead and do this as well. So in the update loop, let's see. We probably want to go ahead and, I think we're always going to want to, this is a whole bunch of hacking stuff for camera movement and that kind of thing, which is going to be split out into other systems eventually. I feel like this is probably where the avatar system should be updated. Let's see. We only do this, though, if a scene state is loaded. So, and if we have a current scene, which I don't think we actually need to wait on that. I think we can always just run it no matter what. Here's a whole bunch of tracking, timing, log updates. Okay. We probably need to split some of this out into other systems, but I think for right now, here's the current zone. Let's go ahead and do the update here. In fact, actually, let's see. Let's go ahead and do this above this, right? We'll do this first. So we'll say avatar system update. And so the state is going to be the address of app state avatar state. And then we're going to pass along p-frame data. And I think that's just a void return type. So we'll update the avatar system state there. So that's that hook. And then the, let's see, prepare frame. We don't have anything for that yet. So I think we can actually kind of skip that for now. So I'm going to blow past that. Render frame, we can skip that for right now. Do we not have... Oh, application shutdown. This is what I needed. Okay. So shutdown game systems. We're going to do avatar system shutdown, right? And that's going to be, again, the address of app state avatar state. Okay. So that's that. All right, and then the last thing is the hot reloading, right? Which conveniently is right here as well. So we have the application lib unload and the application lib on load. And so I think what we actually want to do is, I think the only place we need to hook this in is actually on the reload, right? We don't really care in the unload. In this instance, we only care about the actual load. So when the game library is reloaded, if we are past the boot stage, meaning we're not going to do this the first time that we load out, then we go ahead and do it, right? So notify the avatar system that the game lib has been hot reloaded. All right, so in this case, we'll do avatar system on lib hot reloaded. And again, address of app state avatar state. And that is that hooked in, including hot reloading. So at least all the hooks are in place for at least the life cycle of the system. So let's go back to the C file and update our to-do list here. So we have gamelib hot reload, reload all PFNs for every avatar state. That is done. Integrate into integrate into system application code. Integrate system into application code. Wow, dyslexia hit hard there for a second. Scene interaction and then handle scene. Okay, all right, so we can safely cross off that first one as well too. Why is this bleating? Unknown type name. Eh? Illumina types, okay. Wait a minute, do we have a circular dependency going on here? Oh, that might be why. Shoot. Why does Illumina scene? Illumina types. I think this was only added because of that. Which I guess it really shouldn't be. That was why we did the dynamic allocation. Okay, that's fine. That's why we did that here. Probably, I don't know why we got away with it here. But let's go ahead and just forward declare this. And let's see, do we have... Did we... Well, we didn't forward declare that one either. Interesting. Okay. Not surprised there's issues with that. Let's see, because we're passing the address of everywhere here. So we just need to eliminate that. So here we actually just need to do one more thing. We need to say app states avatar state equals calc type avatar system state, and we'll do mem tag game, and then we have that. Okay. Does that build? Yes. Okay. Let me catch up here. Been a rough day. Found out that the foundation to my house is cracked. Oof. A few months ago, our garbage disposal system started leaking water, and we just noticed it today when parts of the kitchen had water in it. Oof. That sucks. Hope you're having a better day than I have. Yeah, I mean, I am, but I feel bad for you, man. That's terrible. Hopefully, like, is it like a serious foundation crack, or is it just something that could be kind of monitored and backfilled or something like that? I know water intrusion is terrible for foundations, so that's a big oof for sure. If you don't mind me asking, how did you configure the background you have right now? The background? Oh, you mean the are you talking about like the blurred background that I have here that's kind of like shows through everything behind it? Is that what you mean? Is that what you're talking about? Yeah, Potham, that's terrible though. Oh. Sorry to hear that, man. I hope that I'm hoping it's like not a major thing that you have to deal with on there. You are talking about this. Okay, so this is actually so I'm using WesTerm, and there's a little bit of a hack. It's actually kind of convoluted. So WesTerm on Linux does not actually support this by default on KDE. So I actually had to use a plugin. What the hell is it called? Kwin Effects Force Blur. Which apparently is now archived. It's this guy, right? So I had to install this and set it up to actually allow me to get the sort of blurred background, which is super annoying, but it's because WesTerm's sort of KDE background blurring that they have does not play nicely with Wayland when you have high DPI displays. Super specific, I know. So this is a 4K monitor. If it was a 1080p monitor, it wouldn't be an issue. But because the pixel density is greater than 1, or is not 1 essentially, the default blurring that comes with WesTerm does not work. Seems pretty serious. Don't know yet. Waiting to get someone out here to check out the full damage. Yeah, hopefully it's not that huge of a deal. It's your garbage disposal, right? So it shouldn't be a pressurized line. So it might not, I mean, depending on how much water it was, it might not even be related, actually. It could be water intrusion from somewhere else that caused that. But it's hard to say. Because, like, drain lines aren't pressurized, at least. So at least it wasn't, like, your water line that was doing it. Unless it is your water line that's doing it. Is your water bill been high? Singy, how's it going? Good to see you over there on the YouTube side. Okay. So let's look up what we need to do. Scene interaction, loading, unloading, model entities, etc. So that comes with an asterisk because there are two ways that we can handle this. Let me space this down a little bit because I got thinking about this offline and I haven't fully figured out exactly how I want to handle this yet, right? So the sort of hacky way to handle it would be every time we load a zone, we would just reload any of the avatars, right? Which is probably going to be what we want in 90% of the scenarios, except the main scenario that I'm thinking of, which would be the player. So we don't need to like unload and reload the player every single time, right? So theoretically, we could have the avatar system optionally, maybe through configuration, sort of own the transforms, the instance of the model, all of that stuff. And then we just kind of tell the scene about it when we unload one and load the other. Or we do it the sort of simpler way where we just unload all of it and we let the scene handle it. And we just sort of have the avatar system reach into the scene and say, okay, we need these things added. Here's the sort of configuration for it. Do the thing. And then when it gets unloaded, maybe we have some sort of event handler in the avatar system that says, hey, the scene's been unloaded. Kill everything that's been that's loaded, or kill your references to it, right? So the second one would probably be easier to handle. And I think probably what we want 90% of the time. I'm just thinking it might be a good idea, maybe for certain avatars, for it to be owned elsewhere. I just wonder if there's a benefit to even going down that code path now that I'm thinking about it, though, because here's what I'm thinking. Yes, your character is going to go from zone to zone, right? And so, yes, in that case, it makes sense to keep that loaded in memory. But every other avatar is basically going to unload whenever you switch zones, right? You don't need to carry over the monsters from one zone to another. You don't need to carry over the NPCs from one zone to the other. And if you do, again, it'll be an exception case. So part of me thinks maybe to just eliminate this bit and keep it simple. So maybe we just do the scene interaction for now, where we essentially take the configuration that we have and we feed it to the scene to say, hey, add these entities. I think probably that's going to be the way to go. Having a nice setup makes coding 10 times more fun for me. Yeah, I get that. By the way, I do have an article that I wrote with my NeoVim setup. It has some of my WesTerm set up. I don't think it's got all of this stuff because I switched to KDE not too long ago. Is my bot not going to give you the link? I think my bot might be sleeping on the job. Roman General, good to see you. You're starting a refactor, already deleted over 2K lines. Nice. Love to hear it. Simpler is better. All right, let me get the link. Let's see. So here is a link to an article that I wrote up on my website with all of my NeoVim setup. It's got, I think it might have, I don't remember if it has, it's got all the ZSH and that kind of setup. I don't remember if it has terminal setup or not. I don't remember if I included that in here. I don't think so. but it's got everything else. And this is relatively up to date, so I think I've actually even updated it since July. So let's see. Garbage disposal problem was an easy fix. One of the seals that was holding the pipes got cracked. Yeah, that happens with those. Foundation's a whole other problem not related to that. Yeah, I figured as much. A lot of people in my neighborhood have foundation problems, so it's not really a surprise, just sucks to deal with. Yeah, so my house in Florida actually had cracks in the foundation too because it sat in front of a lake. And so that house was built in like 96 or something like that. And so 94 or 96, I can't remember now. But that one was maybe 15 feet away from water, something like that. And so the land just kind of settled and the foundation had cracks in it. It just happens. So hopefully it's nothing too extreme in your case. Cracks are never a great thing, but there's severity, if you've got a foundation crack that's got 1/8 of an inch of displacement, that's not huge. But if it's 2 or 3 inches of displacement, that is a big deal. So, okay. Used to live by a canal in South Florida. One day, the tiles started to pop up from the ground. Woke us all up at night. Yeah, that house had a couple pop tiles in it too. Yep. And I told the new owners that, when we sold the house. We showed them all that stuff. But, yeah. Okay. So, yeah, homeownership is fun. Especially when you have things like that come up. But hopefully it's not a huge issue for you. Kringer's flossed for you, my friend. In all seriousness. All right. All right, so how do we want to do this? I guess what we need to do is we need to open up the scene. And I think I'm going to prototype the... I think I'm going to prototype the function in the C file. And then... One second. Okay. So I think I'm going to prototype this in the scene. Let's go to... Where do I want to put this? Let's think about... I guess when we add... We go to add some of our entity types. We are going to have, this is going to be one of the places where it's going to be super useful to us that we have our own sort of scene to add here, right? So we're going to have a, let's see, do we return? We just get Illumina entity. All right, so let's think about all of the data that we need back from the scene when we tell the scene that we want to load this thing, right? So we're going to be passing a lot of data to it. We're going to be passing model name, well, name probably, model name, model package name, model transform. I wonder if this should, now that I'm thinking about this name is really more of a class than it is a name. Right? Because you can have more than one instance of an avatar. I should probably fix that really quickly before I forget and then want to kick myself later. So we're going to go with, instead of name here, we're going to do type. Right? In name, will not be included in this list, right? So this is really just a blueprint for avatars in general. So avatars, if we go in here, because I know we had a few places that were name, right? So let's do, we do want to keep a name, but we also want a K-name. Well, you know what? Let's do type first, because that will tell me what is broken in here, and we can fix all of those, right? So let's do type. And then let's see. This is going to be type. Type. Okay. So now that that's fixed, let's go back to what we were initially talking about and put name back in here. So this is, the type is basically going to give us a little bit more context of where that connects in as far as the configuration goes, right? So a type is specific to a configuration, right? So we have the player case in here, right? This is the configuration for a player type avatar. That makes a lot more sense than name. And then a name, like each instance of an avatar will have a name, right? So that's the differentiation there. So anyways, in this function that we need to create over here, we need a couple things back. So we need we're going to have all of these things. Let's see, we're going to need the outer entity. We're going to need the inner entity. We're going to need the hitbox entity, or the hit shape. And then we're going to need the transforms of those things. So I guess probably the way to do it is going to be a little bit different than the way that we handle our other entity types, right? So we're going to do, I'm going to do return type void for now, Lumina scene, and then we're going to do add avatar, right? And this is probably going to have, we're probably going to want to parameterize this somehow. Or actually, if we think about avatar state, if we think about the things that we actually need to store within the avatar, which we don't actually have here, we should probably think about this first. So we'll do Illumina entity, right? And we're going to do base entity, right? Illumina entity, model entity, and then Illumina entity, we'll call it hit, right? So this is going to be the top level entity, right? This will be the model entity, and this will be the hit shape entity. So I'm actually kind of thinking maybe we should just pass this whole struct. Right, so maybe here we do avatar, right? And then of course, you know, the struct scene, Illumina scene. Right? And then that will give us what we need to actually do the rest of it. Does it not like you know include that system? Okay. So we're gonna need to have the base entity set. We're going to need, so that we don't have to retrieve it all the time, k transform base transform, k transform model transform. We might not actually need that one. And then k transform hit transform. We're also going to need to know the k model instance, right? Because we're going to need that to trigger different animations, right? So essentially, this is the information that we feed to the scene, and then this is the information we get back from it that we need to maintain in its state anyways. So here, we should be able to just do Illumina add entity, right? And this is going to be our base entity. So we want to pass scene, and then we want to do a k-name for this. So we're probably going to want to construct a new k-name. So we're going to say we're going to do base name, and we're going to set that equal to string format, and that's going to be a name. I think that's a k name, isn't it? That's a k name. Okay, so we want a name. We need the format string first, actually. So we want, how do we want to do that? We want to use the name, right? So I'm going to do k and then underscore base. And maybe we do the type. Or do I do it maybe the other way around? Maybe we do avatar type name base, right? And then we can pass the we can do like that, right? Wait a minute, should be type then name. That name. Okay. And then we can just go here, do k-name create, pass it base name, transform. Do we want to say, when we add this, do we want to provide an already created transform? I don't think so. I think we're going to say no. We can always move it to where we need it afterwards. So we're going to do k transform invalid, and then parent, which is going to be invalid as well. So Illumina entity invalid, right? Right, that makes sense. Okay, so one more thing. Pretty sure. Pretty sure down here. Didn't I have... I think I have to pass the K name as a pointer. We'll have to test that and see how that works. So if you're wondering what I'm doing here, right, this is not a standard replace code, right? So one thing I did offline, I think I talked about this already briefly, was I actually put my own sort of printf in here, or a printf extension, so that I could have my own types here. So we have under string format v, if we trace this down, we now, instead of just using VSN printf, we have this VSN printf extended. And this allows me to insert new codes into here that we can use to print things like vectors, right? So you don't have to split them out in line all the time and put a whole bunch of different formatters in there. And so we can use, for example, %v, and then the number, right? So %v2 is a vector 2, %v3 is a vector 3, %v4 is a vector 4. And then with a dot precision d, so we can say how many decimal places we want to display that out. And so if we use v like that, we could just pass a vector 2, 3, 4 in, and it goes ahead and grabs that and prints it to the string or whatever buffer this way. So there's the vector 2, vector 3, and vector 4. And then I also added one for kname, which is lowercase k. And that automatically calls the kname string get. And so it's just kind of a little convenience thing so that I don't have to call kname string get all over the friggin' place. I could just literally do %k like this and have what we need, right? And that is checked into the 0.11 branch if you're interested. Just realized this video has Shadows of Illumina in the title. Nice to be back in game dev. Yes, we are firmly in game dev territory. In fact, we're probably going to be here for a while. I might have to step into the engine for one or two minor things here and there, but for all intents and purposes, we are going to be in game code world for a while. Hello, Y tabs. Yeah, you're the first one to notice that, actually. So I've had this debate for quite a while going on in my head about tabs versus spaces, and I finally decided to switch to tabs. Now, I know this is like a hot button issue for a lot of people, and for the longest time I didn't really care. Like a lot of editors just sort of default to tabs, right, or spaces rather. But my thought is, if you use a tab, right, the developer can just say in their editor, how many spaces do I want a tab to represent? And they can just easily adjust that. Whereas with spaces, you completely lose that capability. The other thing is because there are one tab takes up, say 4 spaces, which is the default in most editors, technically it makes your code size a little bit smaller, which isn't a huge benefit, but it's something, right? But I kind of like this better, and so that's kind of why I switched to that. It just makes a lot more sense to me. Heresy. Yeah, I mean, here's the thing. Like I said, it's a hot button issue, right? There's lots of people that care about that sort of thing. And I normally don't. But I got thinking about it, and I'm like, you know what? I just want to use tabs instead of spaces. So here we are. If you don't like it, you can fork it and run clang-d on the whole code base as I've done to reformat it, right? Anyway, that's that. Okay, so add entity here just gives us our base entity, and that'll give that to us immediately. So we can say a dot base equals that, right? The other thing that we can get is a base transform, which is going to be now. Let me see. I probably ought to do. Yeah, I guess I could just do it this way. Scene entities, right, which is our base entity. And then I want sub a base, base and then transform, right? So we can get the transform that way. So this is the base slash outer entity that owns everything, right? And then next we have to create the model entity, right? Which we can go ahead and do right away as well. So in this case, we do a.model is going to be equal to Illumina scene add model. And that's going to take the scene, a name, which we actually have to do this same thing again. So I'm going to do this. And we're going to do model name. And this is going to be avatar. And then instead of base, it's going to be model. All right. And I just realized I need to string free base name. And I'll need to do the same thing here with model name. Okay. So we have that. So the name is going to be model name. The transform now is still going to be k transform invalid. Actually, we do need to provide one there, but I'm going to come back to that. The parent entity is going to be a base. Wait, was that parent transform or was that parent entity? Okay. Then the asset name is going to be a model name. And then we have here the package name, which is going to be a model package name, right? Model name. Oh, this needs to be kname creates. As long as people don't mix tabs and spaces, I don't have a preference. I agree with that. And this isn't really like this is not a hill I'm willing to die on, right? I do agree not mixing them is the way to go for sure. But yeah. It was something I thought about, and I'm like, you know what? I've been thinking about it for a while. We do all kinds of experimentation in here, so why not? So I actually ran a formatter across the entire code base, which needed to be done anyways. And so that's a separate commit, actually. Anyway, so we have that. And we need to do a model transform is going to be scene models sub a model. And then we're going to do the, let's see, base.transform. Actually, we're going to have to get this more than once. So let's actually just do, let's do this. Model entity. I guess I could do m equals the address of this guy. Right? And then here I can just do m base transform, and then a model instance is going to be m model, right? So we have all that. And then, so this is going to be the model entity nested under the base entity. Now, the transform, let's see. I know we had default transform in here. So I guess that's actually what we probably should be using for this. Is going to be the a default transform, right? So we're going to use that. And I guess ultimately the model transform will be that, but that's fine. Okay, so last piece of this is going to be the hit shape. Right? So this one, if I recall correctly, yeah, this one was actually underneath the player model, which I guess does make sense. Okay.
You dingus.
Thank you for the follow. Appreciate that. All right, so let's do a const character array hit name. And that's actually just going to be this. So we just need to change this to hit. Right, so we have that. And then we can do a, oops, yeah. Let's see, hit shape. I think we just want hit, yeah. Is equal to Illumina scene add hit shape. Of course, we pass scene. Name is going to be kname creates hit name. The transform, whoops. The transform we're going to use, this does not have sort of a transform that we need passed in, so we're just going to let it create one on its own. Its parent is this time going to be a model. And then the collision shape is going to be the a hit shape. Tag counts, we're not going to have any tags for this yet. Tags may be something we have to figure out. To do tags, because I think I don't remember if I put that in place or not, in terms of whether or not it collides based on the tag. I guess we'll find out. All right, so a hit transform is going to be the address of, or wait, no, it's just going to be scene hit shapes sub a hit. And then we're going to do base transform. And I believe that is everything that we need to know here. And so at this point, this will all have everything it needs to do what it needs to do, I think, to load this in dynamically. So we're going to see about that. I guess we'll have to try it somehow. I guess the thing to do, how am I going to handle... Well, first thing I need to do is add this to the header. So let's do that. Okay. Why is this bleating? Because it wants that, which means I probably don't need that in here. Oh, shoot. Do we have another circular dependency again? Yes, we do. All right. Let's do... Let's do that. Now what's this complaining about? Oh, right, because struct avatar isn't forward declared. Okay, cool. We should probably also have like a remove avatar and things like that, but is there anything I'm not thinking of? Yeah, that should be all we need to do. Okay. So let's give this a try. What we'll do is I'm going to go back to zone 00. And I'm going to take this out. This whole thing, right? Because that's effectively what we're replacing. And then we'll go to Illumina main. And we essentially need to, when we have a zone loaded, we're getting all this player transform stuff and all of these things here, right? Which needs to be transitioned over to use the avatar system instead. So the player avatar itself will outlive various zones, but its world representation will not. So let me think. I guess the next thing to do would probably be to start replacing this stuff with references to that avatar. So I guess we're going to need to go to the game state. Let's see, player states. Do we want to put it in player states? Yes, because this is where all this stuff is. Okay, so I'm going to get rid of all these things. And we're just going to have a struct avatar player avatar. Or I guess I could just, yeah, that's fine. Player avatar is fine. And then we're going to have to fix a whole bunch of things in here. So what is wrong with Illumina types now? Avatar system. Why does that have a reference to avatar system? I don't think we need that. Okay. All right, so I think what we should probably say here is, instead of looking at the transform for this, we should probably see if there is a player like avatar at all, right? So we'll do player avatar and then get rid of this. Right? Which means when we were doing application initialize, we also are going to need to load up the player avatar, which we can do here. So if we do, whoops. If I quit hitting the wrong buttons, that would be great. So we can do app, states, game state player avatar equals 0, right? Avatar do we not have, didn't I add the create. Did I not? Create confirm config. Okay, so we need this. So we need create from config. We need the app state, avatar state, and then a string, right? And that will return to us the avatar. So actually we can just do that. Okay, so where do we get the config string from? We are going to do asset system request text from package sync. Actually, I'm just going to do text sync. We're just going to assume the game package. So we'll do, I think in this case, I need engine systems get asset state. And the name is going to be player. Player, should we do player avatar? Avatar player. Yeah, let's do avatar dot player. Right? And so that is going to give us a k-asset text immediately, synchronously, which is what we want in this place, in this case. Asset, right? So we'll have that. And then we'll want to do a k-assert that the asset exists. And that it has content, right? Here we can then pass the asset content, right? So what this means is we don't have anything called avatar player in our manifest yet, so we need to add that. So what we can do here, I'm just going to add this straight to the top. I'm going to have to replace all of the spaces in here. I guess I didn't format this file. Let's do name equals avatar dot player. Right, and I'm making this one a little bit more official named, right? Because this is probably going to be an asset that we're going to keep around all the way through production of this game. So I want to be a little bit more organized in how I name things. So the way that we're going to do that is we have, if we take a look at our application in assets, we have avatars, right? So this is going to be the path is going to be under assets avatars. And we're just going to have, I think I called it player.kson. I'm not going to bother coming up with an extension for it. Oh, do I have to? Really? Well, that's interesting. Okay. Is this going to require me to, whoops, I can hit the right dingus key here, globally. Wow, that did not work. Okay. How did I get that? All right, I'm going to do that offline. Some reason my search and replace just went bananas there, so I'm not sure what happened. Yeah, mixed tabs and spaces. I hate it. But this is a KSIN file, so we don't have an auto formatter for this, unfortunately. I probably need to write one. Okay, so we have avatar player there. So now we have, let's see, we're going to load up. Load player avatar. All right. So we get the avatar. Create that from config. Is there anything else we need to do at this point? I don't think so. We probably ought to have some better way to do this. To do load configs of known avatars. There is one more thing that I can think of, actually, that I realized isn't here. So we create it from config, right? So this doesn't really tell us like anything about the type, other than it's kind of known through the name. Maybe we have like registered types within our avatar system. And then we can just say create new avatar of type. I don't know. Yeah, we'll have to figure it out. I'm going to go with this for right now. And we'll add something more fancy if we need it. Okay, so we have that. Let's look and see what is next here. So this is player and camera movement. Player K transform. So this is going to be, what all is this doing? So we apply rotation and velocity based off of our previous movement. Okay, so all of this probably needs to be moved. To do move all of this to state machine functions. We're going to take this one step at a time, but all of this stuff needs to come out of here. So for right now, I'm just going to hook this up. We're going to do, let's see. So we get the transform, we get the player position out of that. So we apply. Okay, so we're basically just moving. We're moving the transform here. Okay, so I guess this is going to wind up being player avatar. This is going to be the base transform. Right. And then we're rotating that. Why are we getting this separately? Player K transform. And we're getting the position from that. Why are we doing it that way? I feel like this is kind of a roundabout way of doing things that we don't necessarily actually even really need to do. Yeah, I don't see where that's actually even used. So I'm going to do player position. Don't we have a... Don't we have a move? Or translate, that's what I need. We should be doing app state game player avatar base transform. And then we do a vector 3 add on this, but really all we need to do is apply the player frame state. Oops, player frame state velocity. Get rid of those. Get rid of these. What is this complaining about? Oh, just because we have player avatar base transform. There we go. Okay. So we apply the rotation, we apply the velocity. Do we even need to do this? Player entity transform, player transform. I don't think we actually have to do any of this anymore because it's actually handled by the scene for us. I think all we need to do is just apply these two. At least that's the way I'm going to make it. And if it doesn't work that way, we're going to fix it. All right. So we do need the player position to be able to set the chase camera. So we can actually get that a little bit easier. Let's do vec3 player position equals k transform position get. And then we're going to obviously want the app state game player avatar base transform. Yes, I could make a convenience pointer to this. No, I don't care because we're going to be moving this code anyways. Okay, so that is actually the movement stuff updated. Okay, so this is an application update. So this is sound follows the player. Okay. So all we need to do here is just update where the transform comes from. So this is going to be player avatar base transform. So that's that. This is going to also be that same thing. Okay. And then we're going to have the player. So we need to player model instance. So this is going to be the player avatar model instance for that one. Which means, oh yeah, we do need to cache the animation names, but we're not there yet. So the next one is going to be just transform again. Do we want? Yeah, okay, I guess we do need that. Okay. Player avatar base transform. Oops. All right. So this is the move stop. So this one we're going to need the player avatar model instance. Okay. So when the game is loaded, this is where we are going to go ahead and this is where we're going to go ahead and spawn or add the player into the scene. And we don't need to actually do any of this stuff because we already have it. The only thing that we'll actually need to do yeah, and here's the fix me. We're getting ready to do that right now. Okay, so let's do Illumina scene, add avatar. We're going to want the z.zone scene. And then the avatar we're going to want is going to be the app state game player avatar. Okay. So we'll add the avatar to the scene. And then, let's see, move the player to the spawn point. So move the player avatar, be specific here. To the appropriate spawn point. So that's going to be the player avatar base transform. And then, let's see, default to idle animation. So this is going to be, again, player avatar. And then we need model instance to set the animation. And I think, unless I've boned something, which I probably have, I think that's going to be what we need. Let's see. Let's build. Current scene 2333. Oh, do we not need... Oh. Yeah, I guess we don't need that. Just use it straight from the scene. Or the zone, rather. Alright, let's see how badly this crashes. Okay, didn't crash here, which is a good sign. Okay, so where did we go wrong here? We don't have a string, obviously, for something. That's going to be... Yep. All right, so let's have a look here. Maybe I was wrong about this. Oh, wait a minute. Yeah, that's null. Okay. That is why. So why is that null? Did we never set that anywhere? So we add the avatar. Do we get any errors? Because that should have been set. Yes, we did. That would be why. Unexpected character, comma, at position 19. Okay. That's going to be fairly early on in the file. Let's see. Oh. There's comma right there. Okay. That actually wasn't even where I thought it was going to crash. Okay. That's neat too. So, segfault. Cool. What does the content look like? Let's do... did that not work? Why not? Asset content. Oh, why didn't that work, actually? Or did it? Yes, it did. Okay. Let's view the whole string. Did this get cut off anywhere? I don't think so. Okay. So why are we segfaulting there? Current property. Oh, current property is nothing. Okay. Do we have a bug in our parser? I find that kind of hard to believe. We haven't had a bug in this in forever. Let me re-review this file and see if I did something stupid in terms of format. If I did, it probably should be catching that, but as far as the parser is concerned, tabs or spaces do not matter. I also don't know how far into the file we are at the moment, unfortunately. Curly brace open. So tokenization worked, but actually, did tokenization work or did it fail? No, it looks like tokenization worked. Curly brace open. Wait, is it really the first freaking character of the whole thing? Oh, I'm an idiot. One of the minor details of this is we do not require base level braces. And apparently it doesn't allow it. So I probably ought to figure that out, because that is kind of a bug, but... okay, here we go. So, this is a little bit more understandable. Let's see. So what is the string? So idle, out value. Okay, this could be my usage of the code here. So AV state name. Oh, isn't that a... string sk name. Out value is there. We do have the string. Huh. Why is that foobar all of a sudden? That is a K-name, I'm pretty sure. It is. Avatar state. So this is the... there we go. That ain't right. That's not right. Oh, in fact, this whole thing is rubbish. Yeah. Okay. What did we do here? So this is create new. Let's relaunch this. Because methinks something stupid has happened here. So we should have 0, right? So we create a new avatar. We push that to the state avatars. And then we return the address of that. So I don't think that's the problem. All right, so let's just extract the type. Let's actually put... Let's put A over here and expand its properties so we can see what the heck we're looking at. Why is type quite so long? That doesn't make any sense. That is a K name. We did do... It is in there. So where did we miss... Oh, wait a minute. I'm thinking this is a K name, not a string. That's probably valid. I'll bet if I go here to K name, string get player. Okay, that is valid. Okay, so model name is probably going to be the same thing. Model package name is probably going to be the same thing as well. I can copy this. Maybe not. Doesn't let me. Okay, cool. Good job, debugger, on being so freaking slow. There we go. So if we do this, base character, okay, that's the model name. And then that's the package name. Okay, so those are valid. Let's see. Transform string. Okay, so we extract the transform string. That looks valid. We go ahead and we create a transform. That becomes the default transform. It's been assigned an ID. That's good to go. Shape type string. Oh, interesting. Did we not have shape type? Oh, I think that's wrong. It's hit shape type. Yeah, this should be hit shape type, which means this should be, instead of radius, this should be hit shape radius or hit shape extends. Those are definitely wrong. Which means we wouldn't have grabbed those, which actually is really bad. So we're going to build. And I'm going to go ahead and just put a breakpoint here and restart. Okay, so this shape type is sphere. And the radius is 1. Okay, perfect. Okay, so that is good. States array. So we go ahead and grab the states. And then the state count, 7, okay. Then we allocate an array of that size. Then we loop through here. We get each object at that index. So that's going to be a state config, which will have properties of its own. And then a states sub I is there. Let me just make sure we have a name. Okay, so animation name. So animation name, we'll go ahead and extract. And I'm going to actually take this and go back here to our debug terminal and just plug that in. Okay, so it pulled that in successfully. And then we've got some assertions around getting the from. So the from state count there is 5. AV state from states. Yep, okay, that looks good. Then we go ahead and we get that. I'm pretty confident that that is all correct. So I'm going to go down here, past where we've loaded all these states. So it does trip up in here somewhere. Thank you for the follow, by the way. Appreciate that. No comma separating items in that list. Is that intended? Yes. Yeah. Yeah, our language doesn't require it, and actually it trips it up if you put them in there. Okay, so it's completely... let's see. Let's do A. Yeah, it's completely bollocks all of this data. So where did that happen? So states 0. Didn't we go through state 0 and it was fine? Am I losing my mind here? Didn't we literally... Okay, I'm going to restart. Right, so I'm just going to pass through all of this really quickly. Oh, dumbass. I see the problem. Dumbass. So that's going to be at 142. It was plus plus A instead of plus plus I, like a dongus. Dingus-oriented programming there for you. So I was incrementing the pointer to the avatar, which was moving it further in the array, which was exceeding the bounds of the memory because we only had one element in that array. Nastiness. All right. I'm going to go ahead and remove that breakpoint. So I'll bet that fixes the issue. Yep, does. So let's go ahead and continue this. Okay, so I think we might be good on that front. All right, we're running. All right, so let's go ahead and load. Missed something.
Hope it's going well. Make sure your avatar has mastered all 4 elements for a bug-free experience.
Diamond, thank you very much for the tier 1 sub. I really appreciate that. 24 months, by the way. Holy crap. I really appreciate that that support a lot. Thank you, buddy. Thank you very much for that. Yeah, there will be... I think we do have 4 elements in the game, ironically. I think we actually had... I think we actually spec'd out 4 elements, if I remember. So that's actually pretty funny. Unironically. Okay, so... Why is this Spawning player at blah, blah, blah. Add avatar. So we do have... Oh, we don't have a name. That's why. Right. Because we had changed this to not use name because name doesn't come from here. We need to actually provide one to this function, right? So we actually need to say that. And then here, the same thing. And then just do, I guess down here, once we parse all this stuff, then we could just do a name equals name. We could probably also, we should probably also assert that name is not equal to invalid kname. Right, Illumina main needs to be updated. So this actually has to have a name now, which I guess we're going to call kname create. I'm going to call this player, I guess. Doesn't really matter, at least not at this point. Well, now what is it bleating about? Has a type and it has a name. Oh, I wonder if maybe this type doesn't need, I couldn't remember exactly how this worked. So maybe it might just be, wait a minute, was this was an Illumina scene. Here. I'm wondering if these had to just be these without the pointer. I couldn't remember if these had to be pointers or not. I really need to write that down. I suppose I'll get used to it eventually, but I know with vectors they have to be. Did I? I think I saved it. Yeah, okay. So base name, avatar, player, player base. Okay, that actually is what I'm expecting. Okay, so what is this saying we don't have? Scene entities, base. Oh. Wait. What? Yeah, that should... Oh, I know what I did. I forgot the entity type. I can't use that as a index directly. Not in the scene. Forgot about that. I can't do this as an index. I have to do... Let's split it out. I'll do U30 or U16. Base type index equals entity unpack type index a base. And then this has to be base type index. Could have done that all in one line. This is a little bit more debug friendly. So we need to do this here. So we're going to do model type index, and this is going to be a model. And then model type index here. And then this needs to be down here. And we're going to call this hit type index, hit, and then here, hit type index. Cool. Another failure. Let's see. What did I do? I probably did something stupid here. Ah, tags. Right. I was saying I didn't know if I needed tags. And this, stupidly, is not checking for that. So that's actually an interesting bug. So that is 1290. So this should be if new int base tag count, then we do that. Derp. Hey. So it's not 100% right? But I don't know why we're getting all those trace lines either. But what we're looking at there is this guy is being spawned into the scene now dynamically in code instead of being configured. So it looks like there's a little bit of weirdness in terms of, oh, I think I know why that other transform was there. Where's that trace 9 coming from, though? Recalculate transforms. Oh, wow. Okay. That looks like some debug code that I left in there. That's awesome. 500, I think it was, around line 500. That's what I get for not putting a no check-in around that. And I think over here in the... Now I remember I had that rotation in there. I just don't remember exactly what it was. So it was zone 00. Let me undo this, and I need this transform over here. So this is just model transform. Okay, and then redo that. So the player is no longer in here. We're adding it dynamically. Oops. So we shouldn't even have to actually rebuild. We can actually just relaunch the application. Get rid of the breakpoint. And now it's got a gigantic transform, which means, oh, I nuked the scale. Okay, so what is actually different here? Let's do it this way. Up. Wait, neither one of these have... This is the transform I need. That's why I grabbed the wrong one. What a dongus. Model transform. I was going to say, something about that didn't look right. Okay. And that's still not right. What did I... model transform. So that is the one that I used there. Am I missing something? So, oops. Yeah, X, Y, Z. And then here's the rotation. Quaternion. That looks right. Let me just build for good measure. I don't think I need to, but why is it not showing up all of a sudden? It's not like huge. It's tiny. And face down. That seems fine. Sure. Sure, that's fine. I guess let me change this back to change that back to an identity rotation. Maybe I just have it on the wrong axis. But why is that? It almost feels like we're doing this twice or something. Like this, I think, is what we should be using. So let me look at how did we do when we create this from config? We have the model transform. We feed that into the default transform, which I guess we should probably call. No, we can't call it the model transform. That's right. I don't think it's a problem here. I'm thinking it might actually be a problem with when we're creating we think when we actually go to spawn this into the scene. Zone loaded. Position rotation. So when we go to add the avatar to the scene, the outer entity does not come with a transform. The only thing that does is the model, which we're applying here. Oh, wait a minute. Is this? I feel like we've missed something important here. Some detail. So when we use this, we're essentially saying we want to use the default transform. Oh, I wonder if we should like clone that. Have a good one, Robinson. I got some of the Kenny assets. Actually, some I still have to put some of those in. I don't have. I've got a lot of stuff downloaded. I just haven't actually like loaded it into the game yet. Are the two multiplied since it's a child? Yeah, I don't know. That's what I'm trying to figure out. Like, I don't know where I went wrong with that because it was showing up kind of correctly for a bit. And I don't know what I changed that broke it. It was showing up kind of correct, but the rotation was wrong. So the default transform should be applied to... Oh, wait a minute. I think it actually might have gone... Let me make sure that I've done all this correctly. So we have the base entity is here, right, which is just the entity handle that it gets. We grab the type index from that. We use that to get the base transform, which would have been created when we do this. Free that, that's fine. Then we add the model. In the model, its parent is the base, which is here. Let me make sure argument order and such. So scene name transform, which is the default transform. So that's going to be like the local transform. And then the base is going to be the parent. And then the model name and the package name. Yep, okay, so that's correct. Then we extracted the type handle out of that. Get the entity for that type. And then... yeah. And then we get the base transform and the model instance. And then for the hitbox, which I don't think is wrong, but I can't test it yet because I can't really see the freaking mesh. I think that's correct as well. Is that frustum calling is already in place to avoid rendering static animated meshes that are not visible? We do have it. It's currently disabled for debugging purposes right now. But we do have that capability, yes. I just have it turned off. I feel like I'm missing something stupid here. So base is the parent of model, which is the parent of the hit. It's exactly how it should be. Why is that getting... Why is that getting applied twice? That's what I'm not getting. Yeah, it's tiny. And face down. Not useful. Are we getting any errors here except for the OpenAL stupid thing? No. Okay. Is it then? This looks pretty correct to me. It's probably going to be something stupid. So position, rotation, we get that. Add avatar. We pass that along. We update its transform with the spawn position and spawn rotation. And then all we do after that is set the animation. I wonder, did I do something in update, maybe? Transform, rotate, and translate. I mean, maybe there's something wrong with these, but I feel like that wasn't the issue either. I could turn that off, I guess. That'll just keep me from moving temporarily, but... no, that's not it. Oh, actually, I think I realized. Is it? Is it the... oh, I didn't re-delete this. I wonder if that's what it was. Huh, that's interesting. Probably because they were named the same thing, I'm guessing. Okay. Oops, I need to turn the... where was that? Yeah, I need those on. There we go. Okay, so its default state is kind of wrong, but this is now working through the avatar system, which is awesome. That's way better than what we had before. So that's good. We got a lot of, or at least some of our state out of there. So I think the next thing that we're going to wind up doing is hooking up the state machine and actually using our state functions to move ourselves around instead of sort of those hard-coded, key press functions that we currently have. That's going to be the next thing that we're going to have to do. Really quickly, though, why does it default to... also, what happens when I unload and load? Keeps it. Okay. I'm going to have to fix that. Why does it default to the walking animation? Why does it default to... so move forward sets that. I think that's it. Do we not... move on, stop. Let me grab this real quick. I thought... game zone loaded. Default to the idle animation. That's what we're doing. So when we spawn that in there, why is it... oh. I think I know the answer to that too, actually. That is going to be because let me think about this. That is going to be because in our scene, we had a hack to autoplay the first animation. Which I guess we really don't need this in here anymore. Granted, it's going to make our vampire guy stop dancing, but I think I'm okay with that. Oh, really? So the fact that we are getting any animation at all was luck. How did that... Help me understand that. Okay. Let's do... I'm just going to default this to 0 for now. Fix me. Avatars, which load models this way don't show if this isn't done here. I think I know what that is, but which debugger was that? Yeah, see, it's just randomly picking. Okay. You're talking about this one? It's the good old, shall not be named VS. Anyway, I think this is where I'm going to leave it for now. We actually, I accomplished most of what I wanted to accomplish tonight. So I think I'm good with that. Let's do, push the, okay, we didn't make any Kohi changes, which is good, right? So this, but moved I guess we should say added avatar spawning to scene. Moved state to player. Wait, moved references to player state. And that should probably be moved entity transform references to player state. All right, so on the next stream, we will either continue this or I may actually wind up getting some of it done offline. But yeah, that is, we made some pretty decent progress. What is an avatar? So an avatar is what we're calling something that exists in the world that has a model representation of it. So that could be animated usually. It's got some basic properties like a hit shape, and then it's got a series of states that it can have. Each state can have an animation, optionally. It can have can be transitioned from other particular states that are defined here, and can also have functions associated with it that are auto-loaded based on name, based on the type, and based on the actual state name itself. So we've set up something to load up function pointers for each of these states if they exist, and if they don't, no big deal. So that you can actually use this sort of state machine that we've created to make an avatar sort of do its thing. And so we're kind of moving some of this hacky game code that we just kind of placed in the scene and other places into this, so that we can actually make this work the way we want. So an avatar, the first example of an avatar we're creating is the player, which is moved around by the user. Other examples might be NPCs or monsters. So, all right. With that said, let me find somebody to raid, because I'm a little bit over time, and I do have to get up in the morning for work. So, let's see. Oh, I already see who I'm going to raid. Haven't raided these guys in quite a bit. So, we are going to raid El's Dragoon. They are a team. They're a duo making a game for the NES using 6502 assembly. So they're good buddies of mine, and we're going to go and see what they're up to. Although it looks like it might only be one of them online tonight, but we'll go ahead and see what they're up to. And we'll see you guys later. Thanks for being here. See ya.